Hi class, this is Mrs. Alberg. Grab your notebooks and we are going to take some notes today. The objective for the day is that I can multiply and divide algebraic fractions. So you should have just gone through a Google document that helped remind you of your multiplying and dividing rules for fractions. Now we're going to include algebraic fractions, so our fractions are going to contain variables like an x. Write down this first example. We're going to multiply these two fractions together. Now remember, the multiplying rule is pretty simple with fractions, to multiply straight across the top and straight across the bottom. Now I'm actually just going to write this as a multiplication question. I'm not going to do the actual multiplying. So I'm going to write it as 4x plus 3 times x minus 5. And on the bottom, I'm going to write this as x minus 5 times x plus 3. Now that I've basically turned this into one big fraction, some of you should notice that that's all that just happened, we can use the simplifying rules we learned in Target 1 to decide to simplify. So before I start simplifying, remember, we always want to look at this fraction and decide what can't x be. We need to restrict the domain. So when I look at that x minus 5, I want to say what's going to make the x minus 5 equal 0, and I hope you all by now that no, it's going to be 5. So x cannot be 5. I would look at the x plus 3 in the bottom and say what's going to make that 0, and hopefully when you subtract 3 from both sides you all see that x cannot be 3 as well. So remember, it's really important that we talk about the things that x can't be, because when we start simplifying we won't always recognize those ones. So now that everything's factored, I've restricted my domain, we need to go ahead and look for our 1's that we can divide out. And I see a 1 right here with the x minus 5's. So we'll simplify there. The x minus 5's will divide out to be a 1, and it looks like we're left with 4x plus 3 over x plus 3. There's no other 1's, nothing factors. There's our final answer for multiplying those fractions. Let's take a look at another example. We're going to go through another example. So again, we're multiplying. Now, hopefully some of you realized in the last one that really when you're multiplying, it's like one big fraction. So I'm going to save a little time here and just put some parentheses in. We're multiplying these together times those and those and those. But the problem is that we need to do some factoring here, because in order to simplify, remember, we have to have everything factored. So now we have to go through and factor all of these pieces. So let's start with the 12x minus 18 on the top. This one doesn't have an x squared involved, so this is where I would look for a greatest common factor between 12 and 18, and that greatest common factor will be a 6. So if I undistribute the 6, we're left with 2x minus 3. Now also on the top is that x squared minus x minus 12, and that factors, it's an x squared, so let's check out our rectangle and our diamond here. So we've got x squared, we've got negative 12. We're looking for two things that multiply to negative 12x squared and add to negative x. So it looks like the sides of our diamond are going to be negative 4x and positive 3x. So negative 4x, negative 3x. And my factors are going to be x minus 4 and x plus 3. So I'm just going to list those as well. So we'll keep writing on the top, x minus 4 and x plus 3. We're going to go ahead and do the same thing on the bottom. So why don't you pause your video and take a minute and factor both of those quadratics on the bottom. And then once you've factored them, go ahead and replay, and we'll keep going from there. All right. So here are the factors on the bottom. Now one thing I do want to point out is this second group here, the 3 times x plus 1 and x minus 4. If you look up here at that original quadratic, you'll notice it had a common factor of 3. So you could have in the start, before you used your diamond and your rectangle, you could have taken the 3 out and you were left with x squared minus 3x minus 4. and then you would have factored that from there to get the x plus 1 and x minus 4. Now, if you didn't do it that route, you may have ended up with one of your factors being either 3x plus 3 or 3x minus 12. And you'll notice in those two factors, they both have that common factor of 3 that you could have pulled out to get that final answer. All right, now that we have all our factoring complete, we have to say what x can't be. We always want to make sure we look at that step for a minute here. And if we look at each set of parentheses, the x minus 5 means that when I'm done simplifying, x can't be 5. For the x plus 3, it means x can't be negative 3. For the x plus 1, it means x can't be negative 1. And for that last one, x minus 4, it means x cannot be positive 4. So there's a lot of things here that x cannot equal. Now that we have that step complete, let's look for 1s. Right away, I see the x minus 4s and the x plus 3s. Now, the other thing I notice here is the 6 and the 3. And we know that 6 divided by 3 is 2, so we're going to simplify that as well. And we'll write down what's left. We've got a 2 on the top and a 2x minus 3. And on the bottom, we have an x minus 5. And so there is our final answer. And that x minus 5 doesn't have to be in parentheses, but it can be. Either way, it's acceptable. It means the same thing since there's nothing in front of it. All right, now that we've taken care of multiplication, let's go ahead and look at some division. Taking a look at a division example, hopefully in your review you realize that division is not much different than multiplication. So let's just go ahead and rewrite this as a multiplication question. If I want to write it as a multiplication question, the first fraction stays the same, and then we have to switch it to multiply, and remember we have to flip the second fraction, the one that we're dividing by, and so we'll just flip that one over. Now that I've rewritten it, the process stays exactly the same as the previous questions. The first step would be to factor anything that needs to be factored. In this case, we have no greatest common factors and we have no quadratics, so we're done there. The second thing, remember multiplying, it's like just saying it's one big fraction here, so we'll switch these into multiplying together. And the next thing we'd want to do is say what can't x be. This one takes a little bit more work because I have to solve 9x minus 1 equals 0. So we'll add 1 to both sides. 9x equals 1, and x cannot be 1/9. We know that. And also, we'll do the same thing with the 2x plus 1. We'll set it equal to 0, take away a 1. When I divide by 2, x cannot be negative 1/2 as well. All right. So now we know what x can't equal. We can go ahead and look for our 1s now. And I see a 1 with 9x minus 1 and 9x minus 1. And our leftovers are x plus 2 over 2x plus 1. And there's our final answer. Let's take a look at a last example here. We've got 15x to the third over 3y divided by 10x squared times y over 4y squared. So once again, a division question. Let's go ahead and switch it into a multiplication question. So our first fraction stays the same. Our second fraction gets flipped. And now let's multiply. Now this one's going to be a little bit different. You'll notice that there are no pluses and minuses. There's really nothing here to factor. Let's just multiply those two things together on the top. So when we do our multiplying, we get 15 times 4, which is 60. And I'm going to do the x cubed times y squared. I'm going to write it as this. X cubed is x times x times x. That's x cubed. And y squared is y times y. So we're going to expand it out. Now on the bottom we're going to have 3 times 10, which is 30. We've got a y. Looks like we've got two y's being multiplied together and 2x squared. So once again, expanding it out. Now, the reason I'm just multiplying these numbers together, unlike what I've done in the past, is there's no pluses and minuses here. They're just four different pieces being multiplied together. So now let's see if we can decide what our x and our y can't be. We want to make sure to limit our domain. And when I look on the bottom, really the only thing I can't have for y or for x is 0. They can't be 0. And now we can go through and do our simplifying. 60 divided by 30 is 2. And it looks like 2 of these x's will divide with 2 x's on the bottom. And 2 y's will divide with 2 y's. So on the bottom, we're left with nothing. Now, when we're left with nothing, it's like we have a 1 there, because 1 times all of that would keep it to be itself. So it's like dividing by 1. The denominator now really doesn't change anything for us, and all we have left on the numerator is 2x. You could have written that as 2x over 1, but it's the same thing as 2x. All right, so let's just take a look at these steps that we went through. The very first step always is to factor whenever necessary. So remember, when you're factoring, you're looking for greatest common factors, or you're looking for the x squareds. Once you're done with your factoring, you're going to divide. If you're dividing, you're going to flip the second fraction. This step is only necessary for division. From there, what can't x be? Remember, that's where you set each thing in the denominator equal to 0 to decide what x can't be, because we know the denominator can't be 0. Go ahead and do your multiplying, so basically turn it into one fraction, straight across the top and straight across the bottom, and then simplify your ones. And that is it. So now that you've went ahead and taken these notes, I want you to go on to the Google form, and it's time to do some practice.